is all working. Okay, looks like we're good. Okay, I am hoping that as we go through and do this, so we're going to spend about a week talking about how we use these augmented matrices and use matrices to solve systems of equations. What I'm hoping is that you find that and feel that your brain is working a little bit differently with these problems than maybe some of the other problems that we've done. Okay, that's really what we're after, is kind of increasing our brain capacity to be able to focus on one specific thing and let everything else kind of work out the way that it needs to. So on this one right here, if we're going to solve this 2 by 2 using an augmented matrix and using row operations, remember, we're going to show the shorthand for this. So I'm going to recognize that, hey, this is a 1 right here, so I'm going to do something before I even write it down as an augmented matrix. I'm going to swap row 1 and row 2. So I'm immediately going to write down -1, 4, -6, and I'm going to write it down a 2, a -8, and a -9, and then I'm going to close that in. Now, yesterday a bunch of people called me on not writing that vertical line. Do you absolutely have to have the vertical line if you know what each column represents?
Yes.
Probably not. Okay, I forget it a lot. Did I make a mistake, Lizzie?
There's a no equal sign,
Yeah.
so you have to move the 9 to the other side.
Oh my gosh, let me just see. Thanks. Okay, we're going to say, let me just see what this is. Oh, this should be an equals. Okay, does yours say equal? Okay, would you put an equal to on there? That's a little typo there. So I need to make that positive. Thanks for catching that. That's excellent. Yep, I think we're good. Thanks for catching that. Good eye. Okay, so the first thing we want to do, remember, is we want to turn this into a 1. We go column by column. We get the 1 in the column, and then we use the 1 to make the zeros in the column. So the first thing I'm going to do is I'm going to take row 1, and I'm just going to multiply it by a negative. So if I do that, I end up with a 1, a -4, and a 6. And I still have the 2 and the -8 and the 9. And it's kind of nice when a row doesn't change because you're kind of on autopilot when you write it down. And then we asked ourselves this question repeatedly yesterday. Once you've got a 1 in that column and you're using the 1 to make the zeros, you just look at the 1 you want to turn into a 0. So we're looking at the 2 and we say, what do you need to add 2 to turn it into a 0? -2. So if you write down the -2, that's the number you're going to multiply the row with the 1 by. So we're going to do -2 times row 1, and we're going to add it to row 2. So if I do that, here's what I get. I'm going to ask Crew again. Crew, what's the only row that's changing in this operation?
Row 2.
Row 2 is going to change. So I can be on autopilot on this one. I'm going to write 1, -4, and 6. I just write that one down. And I'm going to go ahead and change colors when I multiply here. So this is going to be a -2. This is going to be a 4. And then this is going to be, oh, whoops, take that back. That's going to be an 8, isn't it? Okay, and this is going to be a -12. So if I multiply everything by -2, I get -2, I get +8, and I get -12. And then I add these together. So -2 plus 2 is going to be a 0. That's exactly what I wanted. And 8 minus an 8, that's going to be a 0. That's okay, we can deal with that. And then a -12 plus a 9, that's going to be a -3. And at this point, we can't put this in that format that we were talking about. We can't get that identity matrix that we were talking about. So somebody want to raise their hand and tell us what the answer is to this? Good, we got quite a few hands up. Keely?
No solution.
How do you know it's no solution?
0 plus 0.
Very good. This says no x's plus no y's equals -3. So that's basically saying 0 equals -3. That's why that vertical line is important in the end there. So there's going to be no solution to this. Everybody good? Okay. So when we're graphing things in 2 dimensions on the xy plane, we're looking for the point where the lines cross. Okay. If we add a third axis to this, we get a coordinate system for 3-dimensional space. A lot of times we'll just call that 3 space. Okay. And what I want you to note about this, and I've got this up here in color, okay, and hopefully the diagrams on your paper work. And this is what we want to notice. Each axis, the x-axis, the y-axis, and the z-axis, they meet the other 2 axes at right angles. So they're perpendicular to each other. So you can kind of see that pretty clearly here. We've got the x-plane right here, we've got the y-plane running right here, and then the z-plane right here. And instead of an ordered pair, we've got an ordered triple that locates things. So if I want to locate a point, I use an x, y, z triple. So I'd go to the x coordinate on the x-axis, then I'd go to the y coordinate on the y-axis, and then I'd go to the z coordinate on the z-axis. So to find this point right here, here's what we do. We go along the x, go in the y direction, and go right here, and then we can locate anything in three-dimensional space using these type of coordinates. Okay? So when we're solving a 3x3 system, it's got 3 equations and it's got 3 unknowns, 3 equations and 3 variables. Okay, and when we solve a 3x3 system, we're trying to find the point where the planes cross, because a system with, or an equation with 3 variables, a linear equation with 3 variables, basically defines a plane in 3 space. So what happens most of the time is we get something like this. Okay, they cross in one single point. But there's a whole bunch of other stuff that can happen that makes things much, much more complicated. They could cross in an infinite number of points in one single line. They could be all exactly the same plane and still have an infinite number of points in common. And there's even a couple ways that we can have no solution. So we could have parallel planes like this one right here, or we could have planes that cross like this, where they cross each other, two of them cross, but there's no 3 of them cross all in one same place. Okay? So this is the verbiage that we talked about yesterday. When we get a matrix in this form right here, we call this reduced row echelon form. And the nice thing about reduced row echelon form, you could think of it as just getting an identity matrix over there on the left-hand side, is we can just read off what the answers are. Okay? And the process of doing row operations to get it in that form sometimes is called row reduction. Some people will also call it Gauss-Jordan elimination, row elimination, stuff like that. It's named after 2 guys, Carl Friedrich Gauss, okay, and Wilhelm Jordan. They both used parts of this and made parts of it a little bit more popular. Carl Friedrich Gauss is called the Prince of Mathematics. Amazing. He was a little boy and he was correcting his parents when they would make arithmetic mistakes. I mean, like a toddler. Okay? Bunch of other cool stuff that he did. Most of the time, we're just going to call this Gaussian elimination. So if somebody says Gauss-Jordan elimination, Gaussian elimination, row operations, row reduction, they're basically talking about the same thing. They're little tiny minor differences, but they're not worth worrying about it. We're going to call them row operations, or we're going to call it row reduction, or we'll just say Gaussian elimination. Okay? We're eliminating all the things and turning them into zeros. All right? Any questions? Okay. So here is our first 3x3. We're not going to solve the entire thing. We're going to do one on the back, and then I'll show you what the assignment looks like. There's one on your assignment that starts like this, and it just says, go through and do these things. So again, part of our brain that we're working on here is the ability to focus on one specific thing and let all the other noise just kind of fall into place. And here's the deal. So here's what we're starting with. This is the original one. We're going to swap the 2 of these. So I'm going to ask crew, which one's not going to change?
Row 3.
Row 3. So we're going to come over here, and we're going to write down, I'm just going to put it on autopilot. I'm going to write down row 3. So this is -3, 6, -9, and -4. That gets to stay where it is. Row 1 and row 2 are going to switch. So this is going to be 1, 2, 2, -1. And this is 2, -4, -8, and 0. Everybody good there? Okay, next one. We're going to do this row operation. So I'm going to ask Dane. Dane, if we do this row operation, which one is not going to change?
1 and 3.
Ooh, very good. I asked him a trick question. He got it right. There's actually 2 that don't change. 1 and 3 don't change. We're actually going to end up changing row 2. So I'm going to write down row 1, and I'm going to write down row 3. And we're going to change row 2. And the way we're going to change row 2 is we're going to do -2 times row 1, and we're going to add it to row 2. I'm going to do this in colors. So we're going to multiply row 1 by -2. So -2, -4, -4, and +2. So the -2 and the 2 make a 0. The -4 and the -4 make a -8. The negative 4 and the negative 8 make a negative 12, and the 2 and the 0 make a 2. Okay, now we're going to do this next row operation, and I'm going to ask Andy. Andy, if we do this row operation, which rows are not going to change?
Row 1.
Very good, row 1 and row 2. So I can put my brain on autopilot, and I'm just going to change row 3 eventually, but I'm just going to go 1, 2, 2, negative 1, 0, negative 8, negative 12, and 2, and we're going to change row 3. We're going to multiply row 1 by a 3, so that's going to be a 3, a 6, and a negative 3. 3 and negative 3 make a 0. 6 and 6 make a 12. That doesn't look very good right now. Let's see. 6 and that makes a negative 3. And that makes a negative 7. We good there?
Mm-hmm.
Okay. Different question this time. Why are they doing this? Why did they choose to do negative 1/8 times row 2? Luke.
Because they need to find the 1 in the second column.
Very good. We got goal number 1, goal number 2, and goal number 3. We're now on to goal number 4. And if you take a look, there's no nice way to turn that into a 1 without introducing fractions into the problem. So you may run across fractions. If we can avoid it, we're going to try and do that. But on this one, we're just going to carry out this operation. And I'm going to ask Jack, what's the only row that's going to change here?
Row 2.
Row 2. So 1, 2, 2, negative 1, and 0, 12, negative 3, negative 7. And then the middle row is going to change, so we're going to get a 0, because negative 1/8 times 0. And then this is going to be a 1. This is going to be a positive, correct me if I'm wrong, 3/2. And this one's going to be a negative 1/4. Okay. Any questions?
None.
All right. Flip the page over. Okay. And you're going to hear me say this several times over the next couple of days. It is not just getting the answer that's important. In fact, I consider that secondary. It's the thought process that we have to go through and the brain stretching that happens while we're doing these. So, on this problem, remember, we had this before. I'm just going to highlight this. We want to make sure we go slowly. Keep things neat, organized, and aligned. I have really crappy handwriting, but I try really hard on stuff like this. If you can avoid fractions, try to, but don't do it at all costs. Go column by column. We want to get the 1s first and then use the 1s to make the 0s, which makes our goals happen in this order on a 3x3. That's goal number 1, that's goal number 2, and that's goal number 3. The 4th goal's right here. It doesn't really matter what you do here, 5th or 6th. This one's the 7th goal, that's super important. And then you're probably going to do 8th and 9th. And by the time you're going to be able to read off what X is, what Y is, and what Z is, and you're all set, we do want to make sure that we write the answers as an ordered triple. We were doing ordered pairs before, now we're going to do ordered triples. Everybody good? Okay. Raise your hand if this really rings a bell. Okay. Keep your hand up if this is easier than the last time you saw it. All right, that's not too bad. Okay. I'll take a suggestion to start off. Great. Samara.
Swap row 1 and row 2.
Perfect. First thing I'm going to do is I'm going to write down row 1, swap with row 2. So the augmented matrix we're going to write down, we've already got one step done. So I'm going to do 1, 4, 1, 10, 3, 3, 2, 16, and negative 2, 6, negative 2, 8. I'll take a suggestion. Jack?
Negative 3R1 plus R2.
Very good. Negative 3R1 plus R2, which means row 1 and row 3 are going to change this, stay the same. So again, I like kind of putting this on autopilot. So row 1 is going to be a 1, a 4, a 1, and a 10. I like that because it's got the 1. Row 3 is going to stay the way it is, so I'm just going to relax while I'm writing that. And then I'm going to change row 2. Negative 3. Whoops, I'll write it up here. Negative 3, negative 12, negative 3, negative 30. 0. Ouch, negative 9, that doesn't look very good. Negative 1, that's a little better. And 14.
Negative 14.
Okay, what would happen if we didn't catch that mistake?
It would be wrong.
You make one tiny arithmetic mistake and you get everything else wrong. It gets super frustrating. It doesn't mean you learned any less, okay? But it does get frustrating. Yeah.
3 times 3 is not 12.
Silly bees.
Didn't we 3 times 4?
Oh, right.
Silly bees.
We good?
Yeah.
Okay. Suggestion? We got this. Goal number 1, goal number 2, crew.
2 times R1 plus R3.
Very good. So what row's changing, crew?
R3.
R3, which means we can just write down row 1 and row 2 without even thinking about it. We like those 1, 4, 1, and a 10. 0, negative 9, negative 1, and a negative 14. And now we're going to do this operation right here. So we're doing 2 times row 1. So we just double everything. So 2, 8, 2, and 20. And add it to row 3. So that's going to make this a 0. That's going to make that a 14. Ooh, that's a 0. That's kind of nice when that happens. And put those together, we end up with a 28. Now, don't say anything out loud. I want you to think about, we've got goal number 1, 2, and 3 taken care of. We're now on goal number 3. Sorry, goal number 4.
Yeah.
We want to get a 1 right there. Suggestion. Jack's got 1. Anybody else? Keely.
That's 1.
Same.
Angela. Okay, Angela, you haven't said anything today. What do you think?
Negative 1/9 times R2.
We could definitely do negative 1/9 times row 2. That's automatically going to introduce fractions though, right?
Indeed.
Okay, we could do that. No doubt about it. Keely.
I actually have a question.
Sure.
Wait, hold on. Just kidding, never mind.
Okay. Gavin.
Row 2 and row 3 swap up.
Okay. So, in some order, we're going to switch row 2 and row 3 because take a look at row 3. Take a look at the advantage that has.
Extra 0.
14 and 28. Ooh. 14 goes into both of those. So I'm going to do it in this order. I'm going to do 1/14 times row 3. So if we do that, we're going to end up with the only one that changes is row 3. So 1, 4, 1, and 10. And 0, negative 9, negative 1, and negative 14. And this would be 0, 1, 0, and 2. And then we're going to swap them. Row 2 swapped with row 3. And that's easy to do. 1, 4, 1, 10. And then this is going to be 0, 1, 0, 2. And this is going to be 0, negative 9, negative 1, negative 14.
I don't like it that way.
Luke.
So if you hadn't done this, would you still get the right answer?
Yes. Yeah, you'd have to work with fractions longer, but you'd still get the right answer. Okay? So now we got goal number 4 taken care of, and we didn't have to introduce fractions. So what am I going to do with that 1? Okay, watch. Watch. Eyes up here. Stop what you're doing. Okay. We're going to be using that 1 to turn the 4 into a 0, and we're going to use the 1 to turn the 9 into a 0, correct? Okay, so would it be okay if I did this? Negative 4 times row 2, add to row 1. And at the same time, what if I did 9 times row 2, add to row 3? Could I do that? What's the only row that's not going to change?
Row 2.
Row 2. We love this one. 0, 1, 0, 2. And let's see what happens here. I'm going to do these in blue. Negative 4 times row 2. So that's going to be 0, negative 4, 0, and negative 8.
Dude, holy crap.
This one's going to be 0, 9, 0, and multiplying by 9, so that's going to be an 18. 0 and 1, that's going to be a 1. Negative 4 and 4, that's going to be a 0. 1 and 0, that's going to be a 1. Negative 8 and 10, that's going to be a 2. Row 3 is going to be a 0 and a 0. A negative 9 and a 9, so that's a 0. A 0 and a negative 1. There we go. And that's going to be a 4. Almost there, just a little bit left.
If you look at it right,
Yeah.
it's a Christmas tree.
Negative 1 times 2.
Very good. Negative 1 times row 3. So if I do negative 1 times row 3, everything else gets to stay the same for the time being. All I'm doing is changing row 3 by multiplying it by a negative. So that's going to change the sign of that, and I have one tiny step left. I'm going to use that 1 to turn that into a 0.
Couldn't you just add them together and then?
We could. Okay, so if everybody catches this, you'll notice that because we've already got zeros over here and we already turned that into a 0, we could just add those two together rather than changing this into a 1. It would change, it actually would work better that way. It's one less step, and if you see that, that's awesome. As it is, this is what we do. Negative 1 times row 3 and add to row 1. So here's what we end up with. So row 2 stays the same. Row 3 stays the same. And we get, let's see, this is a 0, a 0, a negative 1, and a 4, oddly enough. Okay, we're right back to where we started on that one. And then we get a 1 and a 0 and a 0, a 1 and a negative 1, and a 4 and a 2 make a 6. So this is the augmented matrix that is the answer in matrix form. Keely, what did we write down?
Negative 4 to 6.
Close. Other way around.
6, 2, and
6, 2, and negative 4. There's the answer, because remember, this is the x column, this is the y column, this is the z column, and that's the answer column. Okay?
W.
Any questions?
No.